Thank you, Dr. Morrow. Hi, and good afternoon, everyone. I'm Jackie, and as Dr. Morrow mentioned, I'm now doing my postdoc at UNM, and my research interests now are implementing AR in different areas. Well, for example, the emergency response and rescue, and I'm also doing the finite element analysis, topology optimization, and some engineering training. And today, I would like to share some interesting AR implementations in the emergency response and rescue. Okay, I kind of have a problem sharing the slides here.
So maybe stop sharing and reshare. Sometimes that takes care of the, you're gonna stop and then share again and see that.
Okay. Okay. Sorry. Let me stop sharing here.
Yeah, that typically works.
Maybe that's a video. I don't know. Let me try again. Sorry, guys.
No problem.
Tomorrow I cannot share, like the host disabled participants.
Oh, we need to make you co-host again. Yes, we'll make you co-host here. And
okay, great.
Yeah, try it again.
Okay, I think it should work.
Yes.
Okay.
Yes.
Finally. Okay. Sorry for that. And let me continue. So about AR. So there are three necessary points in the concept of AR. So the first one is the interactive. Like with AR technology, you can not only see the virtual objects, but also you can interact with them, control them with your gestures. And the second one is the real world. Well, besides the virtual images, you can also see the real environment too. As you can see here, you can see the apartment, and otherwise it is just called VR, the virtual reality. And the third one is the enhanced. Well, the real environment is enhanced by the virtual images, but the main body here is still the real world. And yes, these are like just two fun, very basic applications just to show the concept of AR. And our team created this called time machine mirror application. And this is the first application designed to assist the first responders in emergency response and rescue and simplify that ERR. Well, during ERR, the first responders, the most critical question is, am I safe to stay and rescue? And because of the continuous structural deformation and possible sudden collapse during the earthquake aftershocks and fires, well, it is crucial to keep an eye on your surroundings while conducting the indoor rescue. And today, the first responders pay attention to their surroundings, well, basically on their own. But you know, when you are concentrated on conducting the rescue, it is very tough to also pay attention to your surroundings. Well, unless it is a sudden collapse, which is very dangerous, people are not sensitive to the slow movement of their surroundings. And we discussed this topic with the Office of Emergency Management in the city of Albuquerque. Well, I was heard that Justin is here today. Thank you very much for this discussion. It really helps. And so these are the primal demands we get from the discussion. So first, let's assume a device helps to remember the present environment for the first responder. For example, well, right after he enters the damaged building. And after some time, let's say 5 minutes, he looks around and the device here can evoke the image from 5 minutes ago and overlaps it onto the real environment. Then the first responder finds that the damaged building has moved a little bit during these 5 minutes. Then he can mirror the deformation with that device. And okay, he decides it is still under the collapse threshold, so he feels safe to stay longer in the damaged building and continue the rescue work. Well, besides the primal demand, they can, well, the first responders also have some more very specific requirements. Well, so first, the device should be contact-free, so they do not need to use an extra hand to control it. They can just control it with their gestures. Then they can define the time range by themselves based on the real set condition, not like something we define it. And the third requirement, okay, the third requirement is a little bit harder because we don't know which building we will go to the next. So when using this device, there should be no requirement for like the beam models or any other models to input. Well, and finally, this is the most difficult one. It's like the firefighters, they only care about the real-time dynamic deformation of the structures, of the like structural and maybe some non-structural but very important components. But you know, the static deformation can include that the initial, maybe the initial construction errors and some non-harmful rigid rotations. That means that even with the blueprint, we cannot use them, because if we directly compare the present building with the design, we will have, like in this figure, like the D1 plus D2. We call the total displacement. Well, what we want is the pure harmful movement, which is only D2 in this figure. So next, let me introduce something about the time machine measure application. Well, we call it the TMM application. Well, the TMM application contains two primal functions. One is called time machine, and the other function is the measurement. Well, after mapping and saving the meshes, as you can see in these pictures, even though the lamp has been moved, there's still like a remember lamp shadow maybe at the original place. This is called the time machine. The application can measure the distance between the shadow and the real lamp. Therefore, we get the function of the measurement across time. And this is the whole design frame of the application. Well, to simplify it, we can have these two basic modules here. Well, the first module is measurement. Three components in Unity are used: the measure manager, the input manager, and the spatial mapping. And the second one is the time machine. Well, we use the MRTK asset directly to conduct the measurement here. And I won't go into the design details to bore you. And the next, let's just see the interface. This is kind of the more interesting part. Well, this is what the real interface looks like. The interface is controlled all by the air type gestures. And thanks for Elijah. These photos are Elijah, my colleague here. This gesture is called air type. And the interface can be divided into two parts. And I will show the functions of each button in a video later. Well, there are some specific design thought here. So first is the color. Well, the color is designed to be high saturation, and we use the optic colors just to distinguish easily the different timestamps. As you can see in the video, actually when you see like multiple virtual environments all overlap together, if we use the like similar colors here, it will be very difficult to distinguish different virtual environments here. And the second is called the timestamp. Well, the same thought, just to distinguish easily. So the first responders, they don't need to remember when did they save the environment. They can just see the timestamp here. And the third one is the automatic font scaling. This is what we see with the 6 meters distance, and clearly this is what we see at 12 meters, while the fonts are, well, obviously too small to read. So we designed the auto scaling function here. With it, the interface will adjust the font size automatically for the users, as you can see here. Well, this is just a demo of what we can do to with this TMM application. And to demonstrate the function and the implementation of the TMM application, we conducted an illustration experiment in a residential house, which is the most common scenario for ERR. And actually, I have a video here, so we don't really need to see these figures. I'll just show the video. Yep, so this is the interface. Set the message here. Okay, so we load the mesh of what we saved. You see the green one, that is kind of the shadow of this lamp. And then we can measure over time. It's about 1.9 meters movement. And I moved it again, okay, about 2 meters. And this is called downsizing. I will explain it later. That you can really manipulate with the whole environment, so you can see clearly what has happened in this room. Okay. Okay, so this is all about the application. And next, I just want to spend like 1 minute to tell you why we choose the Microsoft HoloLens as our platform. Oops. Okay, so the time machine mirror application was programmed on the HoloLens and the Unity platform. And there are actually 3 types of AR devices. The first one is what we used, is the HMD. And the second one is the handheld devices, like the maybe the iPhones you use and the iPad, something kind of like that. And third one is the spatial projector. And because we have to fulfill the contact-free requirements, so that's why we decided to use the HMD. And actually, there are many other HMDs exist now. And here I compared the 16 HMDs published in the last 3 years. And I considered over 20 indexes, from the weight and price to the display sensors, the depth sensors, which is very important, and the computational capacities, and so on. So, well, I won't put many details here, but in summary, HoloLens 2 was selected because it ranks the top 3 in almost every index. Well, the other devices can have an advantage in one aspect, but always have apparent disadvantages in different elements. But HoloLens 2 has the most comprehensive functions, well, including the very important depth mapping sensors. And also the Matrix Unity platform is more accepted in engineering and compatible with many other platforms, for example, the AutoCAD and Solid 3D. So considering all these factors, we choose the HoloLens 2 to be our platforms here. But of course, HoloLens 2 have some device limitations here. So first, that HoloLens needs a steady 500 to 1,000 luminance here for the best performance. And if the environment is too bright, the cameras can be saturated and nothing is seen. And if the background is too dark, the camera cannot pick up enough information and nothing is seen. And well, the luminance of 500 lux is the light of a typical indoor environment. For example, the offices, the grocery stores, and the laboratories. And of 1000, the maximum is the light of a bright indoor environment. For example, the detailed mechanical workshops or the operation theaters. But let's say the HoloLens 2 operates with the best performance in this environment. But that doesn't mean it cannot work well beyond this limit. Actually, when we conducted these experiments, we kind of use the light, like not with that enough light here, and it still works. And also, HoloLens 2 operates with the best performance in the environment within the temperature range of 10 to 27 Celsius degrees, and within the humidity range of 8% to 90%. And well, however, the implementations, out of this recommended range may lead to shorter battery life or sometimes some severe device damage, but we didn't encounter any of these problems. Okay, so finally, this is my future research direction. This is what I'm currently working on, the smoke. Okay, I won't go into details here, just want to show these videos. Actually this smoke, they're all virtual. Yes, I can turn it off again. And you will see, even with all the dust here, well, as long as I can see the lamp there, I can conduct the measurement. The TMM is working just fine. Yeah, I stopped here because, yeah, it is too thick. I cannot actually see it. Okay, so finally, I found some very interesting points when using the HoloLens 2. Well, so first, if you wear eyeglasses, just like me, leave them on, and because we have the brow pad here, it can fit the almost any kind of the eyeglasses. Really nice design, and the overhead strap makes it very comfortable to wear without feeling too tight or too heavy like the other like HoloLens 1. And also the HoloLens 2 can calibrate the virtual images to your eyes. So the HoloLens 2 uses this process to learn about your eye position and to conduct the eye tracking to better render your holographic world. And after this calibration, holograms will appear correctly, even as the visor just shifts on your head. And well, finally, always use it in a safe and well light space with no tripping hazards. And yeah, I learned it in the hard way. Okay, and this is all I prepared for today's presentation. Thank you. And I'm happy to answer any questions about this topic.
Thank you so much, and very interesting presentation. Yes, we've been programming augmented reality on the lab, and obviously we cannot do anything outside, but we are very excited to work with the city of Albuquerque and receive their comments, learn from their limitations that they see in our ideas, and that will make Dr. Shu's and Jackie's impact even higher, because we like to program and we like to come up with solutions, but at the end, the emergency responders, they know what is important. So we're basically depending on their direction. So I don't know if they have questions for you, Jack. I'm not going to put you on the spot, but since Justin is here, he can ask now or later, or anybody else who wants to ask her.
Yeah, sure. Or you can like just put the questions in the chat box or shoot me an email. Both are fine. Okay, I guess I'll stop sharing here.
So I have a question then, if they don't ask.
Okay.
So it's similar to what I asked earlier to Marlon. In reality, the humans, we are averse to trust safety to external devices. You know, we are more safer when we have less gadgets. You know, if we have less gadgets, we're going to be safer, we're going to be faster. What would you comment on that? Because it's true. If you wear the HoloLens, like the slide that you have there, you cannot go running in the mountain. I mean, you're going to trip in rocks, correct? If you have
yes.
So there is a concern. It's a real concern. So what is your comment on that?
Well, first of all, I think I should say, with that concern, like AR is definitely better than VR, because you can always see the real environment. Well, it just, you know, with this virtual images, just position right in front of you, it's very easy to like pay all your attention to the virtual part. But I just want to remember you and remember myself that when design any applications, well, the virtual part is only like the augmented or enhanced, but the main body here is always the real environment. And I think, well, actually the users, they need to, well, try the AR devices, not only the HoloLens. They should try it like with longer times, with even some trainings to get used to it, like to not pay all the attention to the virtual parts. And yes, I totally understand this is a major concern, because I got trapped even in my own apartment. I know exactly where everything is, and you know, when I'm doing the environment. So yeah, I got trapped down. Yeah, but I guess the answer here is the longer time training.
And on that note, since before the next speaker briefly, what about in terms of training faster professions, like maybe training faster? You mentioned a little bit with the smoke, but maybe training or education with AR. Any thoughts on how could you accelerate the learning?
Oh yes, that's kind of a very different topic here. As I said, the HoloLens 2 has this function called eye tracking. So you know, when you are really thinking, your eyeballs will move like in a different way, like you're staring and your eyeballs are moving. So that's kind of, there's a link, there's a relation between the eyeball movement and the conscious, the learning cycles. So actually, I guess HoloLens can really help with the learning cycles by tracking the real-time eyeball movement to see, okay, you are now paying attention, or no, you are not here, you are thinking about something else. I think that HoloLens 2 can really help. And that's a very interesting topic.
Great. Well, thank you very much, and excellent presentation. We'll learn a lot. Thank you.